Hey class, I have already written up 4 graphs and I'm just going to go through them with you. And what I want you to really pay attention to as I go through them is how every single time I do the graph exactly the same way. And I'll point that out again and again. But I just want you to keep that in mind. So the first graph, and I just made these up. So we have a cosine graph. If you notice, I uploaded this page right here that has all of the graphs on one page. And what I've done is I've cut the ones that we need in and put them on the pages. So right over here, you will see this is the exact piece that is right here. So that's just out of the book. What we do then is every time we look out front and I see that the amplitude is 2, but I got a negative there. In the book, it says the amplitude is the absolute value of A, where A is out front. And so you'd have the absolute value of -2, which is 2. I just look and I say it is 2, and then that just flips it. So the amplitude is 2, but the negative flips the graph. So what I've done over here is here's the normal graph of cosine for one period. And if I flip it, I just mirrored it the other way. And so this purple graph is what it looks like if it's been flipped. Okay, in lecture I said we always want to pull this the b term off the x, and then we can see the shift right there. And so when I factor out the half, I told you guys in class that pulling out divides. And so if you took 5 pi over 3 and divided it by a half, that's the same as 5 pi over 3 times 2 over 1. And that's how you get the 10 pi over 3 right there. And then we have the plus 3 still on the end. Okay, once we have that, the period for cosine is normally 2 pi. But if we have messed with it, period is 2 pi over b, whatever b is. And so there's my b right there. So we take 2 pi over a half, we get 4 pi. Now in class, in lecture yesterday, I had said we always do the period and take it and divide it by 4. And the reason why is because if you divide it into 1, 2, 3, 4 pieces, that gives you 1, 2, 3, 4, 5 points. And every time there's 1, 2, 3, 4, 5 things that I want you to track. I'll point the 5 things out every single time. So we do the period and we divide it by 4. And that just cuts it into those 4 pieces, the 1, 2, 3, 4. And here's the 1, 2, 3, 4, 5 cut points. Since it's shifted right by 10 pi over 3, we know that because the minus drives it to the right, a plus drives it to the left. So it's been driven right 10 pi over 3, and on the back end, it goes up 3. Okay, so here's what we do then with that. Since it's right 10 pi over 3, I just go to the right. Where is 10 pi over 3? I don't know, but it's to the right of 0, so there it is. And then this piece is what I add. So if I take 10 pi over 3 and add pi, I'm going to think of it as 3 pi over 3 every time. So we go 10, 13, 16, 19, and 22. Very easy right there. Over here, we're looking at the purple now. And what I see is the second and the fourth point live on the center line. So now we see it's been shifted up 3, so we go up 3. This dotted line here is that center line at y equal 3. And 2 and 4 live on the center line, so I put them right there. And then I see 1 goes down, and it's usually whatever the amplitude is. But our amplitude's been 2, so right here is the 2, and you can see we go 1, 2 down there. In the middle, we go up the amplitude, so we should go up 2. And on this side, we go down 2. And we could figure out what those points are. If this was 3 and I dropped 2, this should be 1. So if you see right there, there's the 10 pi over 3, 1. And 22 pi over 3 should be 1 also, right there. If we are 3 and we go up 2, we should be at 5. And so at 16 pi over 3, we should be at 5. And these are on the center line, so they should be at 3, and they are right there. Um, and so then what I've done for us is I've taken, this is my sketch of it, just using this information and what I know about the picture of the graph for one period. And I put it all into Desmos. And so down here, it is all into Desmos. And I've tried to mark these points. You can see those are the points because that's the x value of the point. There's the 1 and the 5 and the 1. There's these that are on the center line right there. And so we're really, what I graphed is from here to here. So you can see that point, that point, that point, that point, that point. And you can see that up here on my graph. And so, but I've done all of this and I did not need any of this. This was just to check and to make myself feel good at the end. So there's an example of a cosine graph. Now that I've done that, watch how all the next 3, I have 3 more prepared. Watch how they're all exactly the same, okay? So here we turn the page. They even look the same, you see? Like everything is almost, and here's the other ones. You'll see they all look the same. And so here's the next one. It's a cosecant graph. And so we have a cosecant graph. So I've pulled the cosecant in here. This doesn't show up there, but this is the 1, 2, 3, 4, 5. So you have an asymptote, a point, an asymptote, a point, and an asymptote. Those are the 5 things you're going to track in there. So notice this, it says not defined for the amplitude. That's why I said amplitude-ish. And what it does is, notice this is a 1 and a 1 right here. And so instead, that's because there's a 1 out front. If we have a 3 out front, we're going to go 1, 2, 3 above and 1, 2, 3 below. And so that's what happens. And that's why I put amp-ish, because it does do something for us, but it's not the height of a wave, because these waves are like turned upside down, because normally sine would look like this. And here you've inverted both of those pieces. So the amplitude is kind of 3. It's going to help us in the end. The next thing I do, and notice last time I even changed colors to purple, and I did that again. Did it here, and I, did it right there. So I've changed every single time to what I need. And in there, all I'm doing is stripping that off the front. Pulling out divides. So if I divide by 2, we get x. And if I divide by 2, that's how we get the 3 pi over 2. Plus 1 stays. Now the period, I look here, it's 2 pi. So it should be 2 pi over b. So we have 2 pi over 2. That's going to be pi. Always do the period divided by 4. So we're going to do pi divided by 4. Now I look in here and I see the minus takes it to the right by 3 pi over 2. And the plus 1 drives it up 1. Okay, so now I have all of the information. Now down here, we start at the right point, right there, 3 pi over 2. And we're going to add pi over 4. So the 3 pi over 2, I made it 6 pi over 4, and then that way I can add a pi over 4 each time. So 6 pi over 4, 7 pi over 4, 8 pi over 4, 9 pi over 4, 10 pi over 4. I reduced the 10 pi over 4. I should have reduced this in here also. That is actually, 2 pi. So there you have it. But really all I've done is I've started at that piece, and whatever that is, I went up pi over 4, up pi over 4, up pi over 4, and so on and so forth. We did it 4 times because the 4 cuts give us the 5 points down here. Then I look at the graph and I see at 1, 3, and 5, we have asymptotes. So here's the 1, the 3, and the 5. We see it's shifted up 1, so we're going to draw that center line up 1 right there. And off the center line 0 here because it's plus 0 at the end, we're going to do this amplitude-ish. And so if this is 1, we're going to go 2, 3, 4. So there's that point. And in here, we're up 1. So we're going to go 1, 2, 3 down. We should be at -2. If we went 1 and 3, we should be at 4. And if you look here, there's the 4. And the -2 is the 1 down 3 gives us a height of -2. And you can see it's labeled right there. So those are those 2 points right there. And once I have my asymptotes in and I put my points in, I look and the graph says just make a right side up U and an upside down U that hugs the asymptotes. I've graphed it again. So you see I've put the y equal 1. There's that line. I've put the 3 asymptotes in there. That's this one, and this one. And so what we're looking at in my picture is this kind of zoomed in version right here where we're looking at this. There's the up 3. There's the down 3. And the right side up U, upside down U. So you can see 3 pi over 2. I have a 3 pi over 2. That's the green line. And it is an asymptote. 2 pi is right there. It's an asymptote. And 5 pi over 2, that's an asymptote also. We already said the points match, and they lit up right there on the graph. And so this is a picture of that. And the really cool thing is I did not need anything except this information and what I know about the picture to be able to graph it nearly perfect to what that looks like. All right, next one. We see here we've got a secant graph. And so secant, I pulled the secant out. It's the sad panda, I called it in class. And again, it doesn't have an amplitude, so it's an amplitude-ish. And we see that it's a 2 out there. It should be the absolute value of -2. That's what the book says. But I say it's 2, and then that flips it. And so take it however you will. So then I came over here, and in purple, I drew what it would look like if I mirrored it, if I flipped it over the x-axis. So next thing I do every time is I strip the 3 off of there. Divide by 3, divide by 3. That's how you get the pi over 3. Plus 3 stays the same. Period then is 2 pi, so it should be 2 pi over b. There's my b right there. And then we always do the period divided by 4. So dividing by 4 is the same as multiplying by 1/4. And you can see we get pi over 6 in there. One thing, well, you'll see in the next problem, I guess. The plus now, for the first time, that makes it go left. So now we see it's left pi over 3. And it goes up 3. So there's the up 3 right there. Okay, so we go 1, 2, 3. I put my center line in at 3. We were left pi over 3, so I start at negative pi over 3. Negative pi over 3 is 2 pi over 6, negative. And so I'm going to go up whatever that period divided by 4 is. So up pi over 6, up pi over 6, up pi over 6, up pi over 6. And negative 2 pi over 6 plus a pi over 6 is negative pi over 6 plus a pi over 6, you're at 0, plus a pi over 6, you're there, and a 2 pi over 6 is pi over 3. One cool thing, and I mentioned this in class, I'll show you on this one. We can go back and look at the other ones. If you take the right side minus the left side, it should equal what the period is. And so the right side is pi over 3 minus the left side is negative pi over 3. That makes you add, you get 2 pi over 3. And that is exactly what the period was. So you could check that on, let's just check it now since I brought it up. If I take 5 pi over 2 minus 3 pi over 2, that's 2 pi over 2, which is pi. And right here, we said that the period was pi. And in the first one, if I take 22 pi over 3 minus 10 pi over 3. That gives me 12 pi over 3, which is 4 pi. And lo and behold, again, that's what we said the period should be. So you can see if you always do the right side minus the left side. And in here, that's right side minus left side. And here, I've got it written down, but it always should equal the period. And it does. And so, but we just got our cut numbers and we have our center line. Now I come back up here and I look at the flipped version. And I see that at 2 and 4, I have asymptotes. And so here's 2 and 4. You see I've put the asymptotes in there. And then once we have that, I see here it's down 1, but that's because there's a 1 out front. Now we have a 2, so I'm going to go down 2. Here I'm going to go up 2, and here I'm going to go down 2. And those are just those 3 points right there on 1, 3, and 5. Because this is 1, 2, 3, 4, the 5 things that you need to be tracking right there. Since we knew we were up 3 and I went down 2, that should be at 1 and at 1. And you see those are right here. And if we were up 3 and we went up 2, that should be at 5. And that is right there. When I graph it, you can see, and I dotted it in here in red, the part that I have. So there's that point, and there's that point right there. And there's our center line, our asymptotes, and so on and so forth. And so in that circle, that's exactly that picture right there. And all I needed again was that information and the basic picture of what one period looks like of that function. All right, we have one more, and this one's the hardest. And the only one I left out is the cotangent, but I kind of feel I did the sine one in class, and if I did 4 of them here, you should be getting bored by now as you're listening to this and be like, dude, it is just the same. He's just doing the same thing every time. Absolutely. If you need to, watch this again. And I guarantee you can do the only one that I didn't do an example of, and that's cotangent. And if you need me to, I'll write up one and do that also. So here is the last one. It's a tangent graph. And what I want you to notice in here is for the first time, there are no pi's inside. And so notice in here there is a pi inside. In here there is a pi inside. And in here there is a pi inside. And what that does is it makes the shift have a pi in it. And the period over 4 will always have some sort of pi in it. Well, usually. There is a way to not have a pi in there. But then it just makes it a little bit harder. So in this one, there is no pi on the inside. And so again, the amplitude, it says it's not defined. So we have an amplitude-ish, and it's 3. And so there it is right there. Next thing I do is strip the 2 off. We divide by 2 and divide by 2. That's how we get the 5 halves. And then the minus 1 stays. So then the period here is pi. So for the very first time, this is a biggie right here. Notice in all the other ones, period was 2 pi, period was 2 pi, period was 2 pi. And in the one I did in class right here, the period was 2 pi right there. I didn't put the pictures in there. But there's the always period over 4. And this is all explained in the Zoom lecture link to that. So we are on this one. All right, so I've pulled everything out and we're here. And for the first time, we don't have a period of 2 pi. It's a period of pi. And so we still do period over b. And so, or the normal period pi over b, which is 2. We always do the period divided by 4. So pi over 2 divided by 4 is pi over 8. And then now I look here, the plus means we go left by 5 halves. And here I see it's down 1. So I came over here, and to be honest with you, I went over here and I did all of the adding in this one, and I saw that all of the answers remained negative. That's why I put the y-axis this far over. There's the y-axis, there's the x-axis. If you want to know, is I front loaded and I thought that's negative 2.5, and 3/8 is roughly 0.375. So it wasn't going to get up. I just had a feeling it wasn't. And so I did that in anticipation. So if you want the honest answer, when I saw that it was driven left 5/2 and we had to add pi over 8 every time to it, then it made it questionable if we were going to get back to the y-axis. And so then I put my center line in right there, down 1. So there's the negative 1 in there. And we start at the negative 5/2. So there that is. And whatever this is, I just add that every time. So we go negative 5/2 plus pi over 8. And you can see that is right here, this one. And there's the negative 2.1073. Then if I add another pi over 8, it would be 2 pi over 8. I know that's pi over 4. But if I do that, we're at negative 1.7146. Add another one, we're at 3 pi over 8s that we've added now. When I do that, you see the negative 1.3219 right there on the bottom. And the last one, we would add 4 pi's over 8s to it. And when I did that, we were at negative 9292. So that's how I got those answers. But did I do anything different than any other one? No. Here we went left pi over 3, and I went up pi over 6, up pi over 6, up pi over 6, up pi over 6. Here we went right 3 pi over 2. And from here we went up pi over 4, pi over 4, pi over 4, pi over 4. Here we went right 10 pi over 3. And then we went up a pi, up, and so on and so forth. So in this one, we just start at left 5/2, and then we go up pi over 8, up pi over 8, up pi over 8, up pi over 8. That's all that it is. And it's just these don't match because there's not pi's in both. And so that's the only reason these numbers get weird. But who cares? That's the honest answer, is who cares, really? That's the truth. That shouldn't bug you at all. When I look up here, I see that the middle one has an asymptote. And so of my 5 points, there's my middle one. I put the asymptote there. And I see that 1 and 5 stay on the center line. And so there's 1 and 5 on the center line. They're both down 1. And so you can see that those are right there. And then I see at the other two, we go up 1 and down 1, but that's because there's a 1 there. And so we have a 3. And so from here, if I go up 3, so we're at negative 1 plus 3, we should be at 2. And you can see right there, we're at 2. And here, if we're negative 1 and we go down 3, we should be at negative 4. And that's right there. So that's how I got those. And I know exactly what those coordinates are. And I put them in here, not in decimal form, even though I did them over here and I have them all in decimal form. Then if you look here, here's the 1, 2, 3, 4, and there's the asymptote. And so this and this is exactly what we have right here. So you're seeing that piece. Those two are the same. So every single one is done exactly the same. Grab your amplitude and see how far that drives the thing. Pull any number that's on the x, you have to strip it off. That number affects the period, and then you're going to always take the period and divide it by 4. You're dividing it by 4 because 4 cuts, give us 5 points. And every single one of these, again, I'm going to put it right here. You have 1, 2, 3, 4, 5. Asymptote 1, 2, asymptote 3, 4, asymptote 5. 1, 2, 3, 4, 5. 1, asymptote 2, 3, asymptote 4, 5. Point, point, asymptote 3, point, point for 5. Asymptote 1, point 2, point 3, point 4, asymptote 5. So every one of these has 5 things. And those 5 things you must know how to get. And I've shown you now 5 of the 6 graphs. And so the only one I didn't do is a cotan graph. But if you've seen how I've done all of these and they're all the same, this one's no different. The only thing to be careful of is 2 pi, 2 pi, 2 pi, 2 pi, pi, pi. And so the cotan one will have a pi period instead of the other one. So hopefully that helps you guys. I'm going to upload this now, and then I will post the link I don't know why I'm telling you this, because it'll already be done by the time you watch it. So here you go. All right. Take care, you guys. We'll talk soon. Bye-bye.